morning, everybody. We are going to learn in this day the salt and types of salt. After that, hydrolysis of salt. So first of all, see what is salt. We know the neutralization reaction which is introduced by the scientist Arrhenius in previous periods, last periods. What neutralization reaction? The reaction in which acid reacts with base in aqueous solution to form the salt and water is called as neutralization reaction. The reaction in which acid reacts with base to give the salt. So what is the definition of salt? The reaction in which acid reacts with base to give salt. The reaction in which acid reacts with base to give salt. This is salt. For example of salt, any acid, for example HCl, hydrochloric acid, reacts with base NaOH. Hydrochloric acid reacts with sodium hydroxide NaOH. Then it gives what? This HCl breaks to give the H plus and Cl minus ions. Again NaOH breaks to the Na plus and OH minus ions. These cations of base can react with anions of the acids to form the NaCl called as salt. What? These cation of the base and anion of the acid combines together to form the salt. Acid and base react with each other to form the salt, and remaining H plus and OH minus combines to produce water. So this is the salt. Then see the types of salt. There are 4 types of salt. How much? 4 types of salts. Types of salt. There are 4 types of salts. Name of that. First salt, salt of strong acid and weak base. First type of salt, the salt of strong acid and weak base. Any strong acid. Suppose strong acid HCl, weak base acetic acid CH3COOH. See again, strong acid HCl, weak base acetic acid, strong acid HCl and weak base NH4OH. Strong acid HCl and weak base NH4OH can combine together. By breaking this HCl, it gives H plus and Cl minus. Again, NH4OH breaks up to the NH4 plus and OH minus. Cations of the base and anions of the acid can combine together to form the salt. So the example of strong acid and weak base is NH4Cl. NH4Cl, ammonium chloride, is example of salt of strong acid and weak base. Another example, suppose here strong acid H2SO4, strong acid H2SO4 and weak base NH4OH is taken, NH4OH. By breaking this, it gives what? It gives 2H plus and SO4 minus. Again it breaks to NH4 plus and OH minus. Then these two hydrogens and hydroxyl ion combines together to produce water, but in H2SO4 there are two hydrogens, so we have to require 2 moles of base, 2 moles of base. So NH4 taken twice SO4. Another example, NH4 taken twice SO4. Ammonium sulfate is the salt of strong acid and weak base. Another example, likewise that we can prepare the number of examples of strong acids and weak base. Suppose strong acid H2SO4, then weak base another, any weak base can take and can prepare the number of examples depending upon the X. Then second one is the salt of strong base and weak acid. Salt of strong base and weak acid. How to prepare that? For that purpose, take the strong base NaOH, strong base NaOH plus weak acid formic acid HCOOH. Strong base NaOH and weak acid formic acid. By breaking that, it gives the Na plus OH minus, here HCOO minus and H plus. This OH minus H plus to produce the water, and remaining HCOONA. Example, HCOONA, that is sodium formate. Sodium formate is the example of strong base weak acid. Another example, suppose KOH is the base, that is strong base, and weak acid CH3COOH, acetic acid. When these two combines together, we get the salt of strong base weak acid. How? This OH and H can produce the water, and the remaining CH3COOK, the potassium acetate, is a salt of strong base and weak acid. CH3COOK, potassium acetate, is the example of strong base and weak acid. Likewise that we can produce the number of examples. Another example, suppose HCOOK, potassium formate or potassium acetate, sodium formate. Likewise that number of examples, the CH3COONA, sodium acetate, in which strong base and weak acid. Then third type of the salt, salt of strong acid and strong base. Third type of salt is a strong acid and strong base. Both strong acid and strong base can combine together, such as H2SO4 is a strong acid and NaOH is the strong base. By breaking that, it gives 2H plus and OH minus here. Then how to form the salt? These two hydrogens and two hydroxyl to give the water, then remaining Na2SO4 So example is Na2SO4 sodium sulfate. Sodium sulfate. Another potassium sulfate K2SO4. That is K2. K is coming from the potassium hydroxide, strong base, and SO4 from the H2SO4. So number of examples are prepared from the strong acids and strong base. So what is the salt and the types of salt? First is the strong acid, weak base. Example ammonium chloride, then ammonium sulfate. Salt of strong base, weak acid. Example sodium formate, sodium acetate. Potassium formate, potassium, sodium acetate. Then third, salt of strong acid and strong base. Examples sodium sulfate, potassium sulfate. And last type of salt is the salt of weak acid and weak base. Both acids and bases are taken as the weak acid and weak base. So fourth type, salt of weak acid and weak base. Weak acid and weak base, both are the weaks. How to form the salt of weak acid and weak base? Weak acid, suppose CH3COOH, acetic acid is the weak acid, and weak base NH4OH. Then hydrogen from this acid combines with hydroxyl of that base to form the water, and remaining is the salt. The example is CH3COONH4 called as ammonium acetate. Again example, ammonium formate. It is prepared from the formic acid is the weak acid, and ammonium hydroxide is the weak base, etc. So these are the 4 types of salt. Remains that all types of salt: strong acid, weak base, salt, then strong base, weak acid, third salt of strong acid, weak, strong base, and last is the weak acid and weak base. Then next term is the hydrolysis of salt. The next term, hydrolysis of salt. Hydrolysis, that is water. What is the actual definition of hydrolysis of salt? The reaction in which cations or anions or both ions of salt. Salt. Whenever salt is mixed, then it gives cation, anion, or both cation and anion. The reaction in which cation, anion, or both ions of salt reacts with water to produce acidity or alkalinity, that is basicity, is called as hydrolysis of salt. So the definition: the reaction in which cations or anions or both ions of salt reacts with water to produce acidity or basicity acidity or basicity or alkalinity in solution is called as hydrolysis of salt. The reaction in which cations means what? Positively charged ions, anions negatively charged ions, or both ions of salt reacts with water to produce acidity or basicity, that is alkalinity, in solution is called as hydrolysis of salt. We know there are 4 types of salts. All these types of salts undergoes hydrolysis, then it produces acidity or basicity here. First type of salt, that is hydrolysis of salt of strong acid and weak base. 2 marks question in board pattern can ask as explain hydrolysis of salt of strong acid and weak base, and you know the examples of strong acid and weak base just a minute before. So hydrolysis of salt of strong acid and weak base, how to explain? See here, consider NH4Cl ammonium chloride. Consider ammonium chloride. Ammonium comes from the ammonium hydroxide, that is weak base, and Cl comes from the HCl, hydrochloric acid, that is strong acid. Consider ammonium chloride is salt of strong acid and weak base. Then the salt NH4Cl dissolved in water. The salt NH4Cl dissolved in water, aqueous. Water means what? Aqueous solution. It dissociate as follows. Whenever the salt is dissolved in aqueous solution or water, it dissociate as follows. NH4Cl plus H2O. NH4Cl, that is salt, plus H2O. This H2O is breaks up to give the H plus and OH minus ion. Hydrogen and hydroxyl ions. This H plus combines with Cl to form the HCl, and OH combines with NH4OH to form the NH4OH ammonium hydroxide. This hydrochloric acid is the strong acid. Ammonium hydroxide is the weak base. HCl is the strong acid and NH4OH is the weak base. According to ionic theory, whenever the ionic theory is applicable to this equation, it gives the ions. According to ionic theory, this salt breaks up to give the NH4 plus Cl minus ions plus H2O water on right side. This is strong acid. This ionic theory is applicable for only strong electrolytes. Understand? This ionic theory is applicable for only strong electrolytes, means what? Strong acids and strong base only, not for the weak acid and weak base. This one, according to ionic theory, this strong acid breaks to give the H plus and Cl minus ions. But this weak base NH4OH does not break up, because ionic theory is not applicable for the weak electrolyte. It remains constant. NH4OH remains constant. So in this equation, left side and right sides, some ions are the common ions. Which are that? Cl minus, here Cl minus, chlorine minus ions are the commons on both sides. By cancelling common ion from both sides, by cancelling common ion from both sides, by cancelling common ion from both sides, such as chlorine minus, chlorine minus. After cancelling them, it gives NH4 plus ammonium ion possess a positive charge, that is cation, plus H2O water. Then it gives what? In another way, another side, NH4OH ammonium hydroxide plus these H plus ions. This equation says that cations of salt reacts with water. Cations of salt reacts with water to produce excess H plus ion. Hence, this solution becomes acidic in nature. Having the pH less than 7. Understand? This equation can show cations, according to definition of hydrolysis of salt, cations reacts with water to produce excess H plus ions, that is the acidity or acidic in nature, having the pH less than 7. Then another hydrolysis of salt of strong base and weak acid. Next type, hydrolysis of salt of strong base and weak acid. For that purpose, consider one salt. That salt is made up from the strong base and weak acid. Suppose that salt is CH3COO-Na, sodium acetate, which is made up from the acetic acid is the weak acid, and sodium hydroxide is the strong base. Consider sodium acetate is the salt of strong base and weak acid. Strong base and weak acid. The salt sodium acetate CH3COO-Na, the salt sodium acetate CH3COO-Na dissolved in water aqueous solution, it dissociates as follows. Whenever this sodium acetate dissolved in water, it dissociates as follows. We get the equation CH3COO-Na plus H2O. On right side, it gives CH3COOH plus NaOH. How? By breaking this water, it gives H plus and OH minus ion. H plus attached to the COO to form the acetic acid, and OH to the Na, it gives the sodium hydroxide. Acetic acid is the weak acid. And sodium hydroxide is the strong base. So we get the weak acid and strong base. According to ionic theory, here according to Ionic theory, whenever the Ionic theory is applicable to the above equation, applicable the Ionic theory, according to Ionic theory, it gives ions, that is salt, it gives ions CH3 COO minus plus Na plus H2O on right side. This is weak acid, weak electrolyte. Ionic theory is not applicable for the weak electrolytes, hence it remains constant, cannot break to the gives ions, it remains constant CH3COOH, that is weak electrolyte. But this strong base breaks up to use the Na plus OH minus ion. Ionic theory is applicable for only the strong base, strong electrolyte, to use the ions. So in this reaction, Na plus on both sides are the common. So cancel that by cancelling common ion, from both sides, we get Na plus cancelled, then CH3 COO minus plus H2O, then CH3 COOH acetic acid plus OH minus. It since that this equation indicates that these are the anions carries the negative charge. Anions of salt reacts with water to give the excess of OH minus ions. Therefore, this solution is basic in nature. Why it is basic in nature? Because anions of the salt reacts with water to produce the excess of OH minus ion. So this solution is basic nature, having the pH more than 7. Having the pH more than 7 means to what? That solution is basic in nature or shows the basicity. So this is the hydrolysis of salt of strong base and weak acid. After that, see the next third, that is hydrolysis of salt of strong acid and strong base. Hydrolysis of salt of strong acid and strong base. Both are the strongs, acids and base. Consider NaCl, sodium chloride, is salt of strong acid and strong base. NaCl, Na from the NaOH, that is strong base, and Cl from the HCl, strong acid. NaCl is the salt of strong acid and strong base. Then the salt NaCl, dissolved in water, aqueous solution, it dissociates as follows. Whenever this salt is dissolved in aqueous solution, it dissociates as follows. How? NaCl plus H2O, then it gives what? The H plus from H2O combines with Cl to give the HCl. Then OH from water combines with Na to give the NaOH. HCl is the strong acid. HCl is the strong acid and NaOH is the strong base. So this is the salt of strong acid and strong base. Then this equation is applicable, the Ionic theory. According to Ionic theory, when Ionic theory is applicable to our equation, And you know that ionic theory again and again. This theory is applicable for only the strong electrolyte, not for the weak electrolytes. According to ionic theory, this salt breaks up to give the ions Na plus Cl minus. This salt is breaks up plus H2O, but in right side, this is the strong acid breaks to give the H plus Cl minus and strong base Na plus OH minus. In this equation, which are the common ions? Na plus on both sides, then Cl minus, chlorine ion on both sides. By cancelling common ion from both sides, Na plus, Cl minus, Cl minus. By cancelling common ion from both sides, we get H2O, then H plus OH minus. But in this equation, this water cannot react with any cation or anions. Water, according to definition of hydrolysis of salt, water cannot react with cation or anion, so it cannot indicate the acidic and basic nature. So it's seen that this water neither reacts with cation nor anions, but in this reaction both H plus and OH minus ion are the equals. Both H plus and OH minus ions are the equals. Hence this solution becomes neutral in nature, having the pH exactly equal to 7. In this equation, both H plus and OH are the equals, then it does not give the acidic or basic nature. This solution is the neutral in nature because it is the salt of strong acid and strong base. So this is the third salt. Then see the last third one, hydrolysis of salt of weak acid and weak base. Hydrolysis of salt of weak acid and weak base is the last hydrolysis. Consider the salt of weak acid and weak base. Weak acid and weak base salt, ammonium acetate, CH3COONH4 is the salt of weak acid and weak base. The salt ammonium acetate, CH3COONH4, ammonium acetate dissolved in water aqueous solution, it dissociate as follows. Ammonium acetate dissociate as follows. So the ammonium acetate CH3COONH4 plus H2O, it gives acetic acid CH3COOH plus NH4OH. In this equation, acetic acid is the weak acid and ammonium hydroxide is the weak base. Both electrolytes are the weak acid and weak base. Then according to Ionic theory, this salt gives the CH3COO minus plus NH4 plus ions plus H2O. This salt gives the cation side and ions. But in this side, both are the weak electrolytes. Weak acid and weak base, it cannot applicable for the Ionic theory. It remains constant, that is CH3COH plus NH4OH remains constant. Both are the weak electrolyte. So in this reaction, on both sides there are not any common ions. We cannot cancel the common ions. There are not any common ions. So this equation indicates What indicates? These are the cations and anions. According to definition, both the cations and anions reacts with water, but does not use the H plus and OH minus ions. This reaction does not use the H plus and OH minus ions because in the acetic acid and NH4OH, both are the weak acid and base, but exactly does not use the acidic or basic in nature. So it is the neutral in nature. This is the neutral in nature. But understand this point. For the salt of, for hydrolysis of salt of weak acid and weak base, understand this point. Depending upon relative strength of weak acid and weak base, the nature of solution becomes decided. That is acidic, basic or neutral. How? If Ka greater than Kb, Ka dissociation constant of acid greater than Kb, then solution is acidic in nature. Second, if Kb greater than Ka, dissociation constant of base greater than dissociation constant of acid, then solution is basic in nature. And third, if Ka and Kb both are equal, then that solution is neutral. So only hydrolysis of salt of weak acid and weak base, these terms are applicable. Depending upon the strength of acids and base. If Ka greater than Kb, then acidic in nature. If Kb greater than Ka, basic in nature, and both are equal, K and Kb, then that solution is neutral in nature. Okay, thank you.